Okay. To think about the genome and genomics, I like to think about the chicken and the egg. Now, a chicken is an animal with feathers, eyes, a beak, trillions of cells. The egg is a single egg cell. So where does the information come from to turn an egg into a chicken? This is an age-old problem, and people have thought about this for thousands of years. But since at least the 19th century, scientists have decided that life is nothing but physics and chemistry. So where is this physical object that gives the information that turns a chicken from an egg? I think some couple misses in that word. So yeah. Should we just continue to go?
Take a pause before.
Okay.
Yeah, anytime. But yeah.
But whenever the light is on, then that means that it's recording. Is that what? Okay. So
Is the volume okay?
Yeah, the volume's good.
Okay.
okay. And I'll try not to flick my eyes over to you. Okay. Right. All right. To think about genomes and genomics, I like to think about the chicken and the egg. The chicken is an animal with feathers, eyes, a beak, and trillions of cells. The egg is a single cell. So where does the information come from that turns an egg into a chicken? Now this is an age-old question people have thought about for thousands of years. But since at least the 19th century, scientists have thought that life comes from the same physical chemical processes that we're all familiar with. So where is the physical object that gives the information that turns an egg into a chicken? Okay.
Whenever you're finished with a
Mhm.
section,
Mhm.
make sure to keep just sort of, you finish your sentence and then keep looking at Kristen silently for like 2 seconds,
Okay.
2 full seconds, so that we sort of have a tail at the
Okay.
end.
Great.
One second. Cool.
We now know that this information is in a very large molecule called the DNA. The DNA is made out of 4 different types of smaller molecules, which we put the label A, C, G, and T. It's actually a string where these A, C, G, T letters are arranged over and over again in different patterns. And so the genome is all of this DNA in an organism and all of that information.
Even a little bit longer at the end.
A little bit longer?
A little bit longer of a pause before.
Okay.
Yeah.
Okay.
That was better.
So when it seems like the end, would it be helpful if I just did that? Okay.
So I guess for me it's a little helpful if I gesticulate. Is that bad or more natural because that's what I do when I teach. So.
Right. I do it a little bit.
Mm-hmm.
Just give me a couple.
Okay. All right. So the human genome is made out of 20 different strings, and if you were to take the genome and stretch it out end to end tight, it'd be about 6 feet long.
Yeah, I mean that's okay.
That kind of.
Yeah, try not to be crazy.
Okay.
But yeah.
So, but it doesn't
Just
affect.
hearing things, is that the problem? It's
Yeah, just a little bit
yeah.
of sort of fabric.
Okay.
Because it's like synthetic material. You
Right.
get that.
Right. Mm-hmm.
Yeah, I mean I think we can make it work.
So at the end of this one, I'll just start moving my fingers.
Okay.
just
All right.
to-
Sounds
yeah,
good.
yeah.
Mm-hmm.
Look at the camera for 1 second. Great. Okay, I'm good to go.
So the human genome comes in 23 strings, and there's about 3 billion letters. And if you put this all tight end to end, it'll be about 6 feet long. And there's 100 trillion cells in your body. So if you put all of the strings end to end, it'll go all the way to the moon and back to Earth 30 times. That's the amount of information in your body.
Excellent.
Okay. Trying to follow a script gives me more of a blank in my brain than if I were teaching, which I would be normally like fun to
It's a
answer.
lot of pressure, because then you realize the
That's
wrong
right.
word, and then you got,
Okay.
Okay. There's 3 billion letters of the human genome. This is about 6,000 books worth of information. Okay. Okay. All right. Okay. So there's 3 billion letters of the human genome. This is about 6,000 books of information. Tells the human egg how to make a person. Now this information is arranged like the English alphabet. So think of the word, say, eat, E-A-T, and ate, A-T-E. It has the same letters, but the order makes the meaning different. And this is how the human DNA works. There's the 4 letters that's repeated in patterns, and it's really the order that makes a difference. And so we want to know the order, and this is called sequencing.
So once I get in. Okay.
Okay, so a key question that biologists always ask is, what's the information in the DNA that makes, say, a white cat different from a black cat? Now, it turns out this is a very hard question. You may think that there's many different kinds of people in the world, but it actually turns out we're all identical in our genome for 99.7%. So, if I wanted to know what makes a white cat different from a black cat, this is sort of like looking for a needle in a haystack.
Okay. 1 second. Okay.
So the idea of genomics is to actually sequence the whole genome first. Okay, let me start again. So the idea of genomics is to sequence the whole genome first. And for this single task, we know how to do this very, very well. 30 years ago, we were sequencing maybe 10 letters per day. Now, we can sequence 300 billion letters per day. That's a lot of improvement in our technology. In fact, we have sequenced the whole human genome over and over. So we have all that information at hand, and for genomicists, now what we want to do is to ask how that all comes together to produce the information that makes an egg into a human.
Great. Ready when you are.
So this is the main idea of genomics, to systematically and efficiently measure everything and figure out how it all goes together. This requires us to develop new technologies for measurement and then use modeling, mathematical modeling, computations to figure out how it all goes together.
Should we wait for that beeping?
Oh, more beeping.
Alright, well, I'll keep it rolling so that as soon as that's over, you can just get started.
Okay. So it's like this. Suppose you're in a car and pull down the window and you wonder, how does that work? Instead of doing that, suppose we had every part in the car all laid out and we try to figure out how the whole car works. And this is how genomics works. And the nice thing is, somewhere along the line, we find things that we hadn't anticipated, like how does the engine turn? So in the next set of videos, you'll find all the interesting things we apply genomics to in various different areas of biology. I think I'd like to do the last one again. So it's like this. Suppose you're in a car and you pull out a window and you wonder what makes the window go down. Instead of doing that, we can take every part in a car and put it all out and ask, how does it all fit together? And when we do that, we find and learn new things that we didn't anticipate, like how does the engine turn? This is how genomics works. And in the next set of videos, you'll find all kinds of interesting applications of genomics to all areas of biology and biomedical sciences. Okay.
Okay.
To think about the genome in genomics, I like to think about the chicken and the egg. The chicken is an animal with trillions of cells, feathers, eyes, and beaks. The egg is a single cell. So where does the information come from to turn this single cell into the whole animal? Now this is an age-old question that people have wondered about for thousands of years. But since at least the 19th century, we realized that life is physics and chemistry. So where is this physical object that gives the information that turns an egg into a chicken? Is it better? Okay. Should I do the next one too?
Sure, why not? It's, yeah. Well, let me cough first.
Okay. Okay. So we now know that this physical object is a very large molecule called the DNA. The DNA is made out of stringing together 4 smaller molecules that we call nucleic acid and name ACGT. So the genome is all of the DNA and its information in an organism.